concise, quick facts to, make sure that you know what you're learning about. But yeah, I really like this book. I might actually get some more of these about different topics if you guys would be interested. Just let me know. But yeah, so today I believe we are on chapter 5. I hope you all are having a fantastic day. I hope if you got everything done that you needed to get done, wanted to get done. If you haven't gotten it done yet, I hope you find the strength and determination to get that stuff done as well. Okay, so we're actually starting a new unit today. So unit 2. Okay, so we got a new unit today. So unit 2, the chemistry of life. Alright, so chapter 5, atoms and molecules. So, matter describes everything that we can touch, taste, see, smell, or feel. Matter is anything that has mass, which takes up space. The smallest unit of matter is the atom. Atoms are so small that they cannot be seen by the human eye or by a compound microscope. It's from the Greek word that means cannot be divided. This is the smallest unit of matter. As an atom absorbs energy in the form of heat, light, and sound, it vibrates and then releases that energy. This is because atoms prefer to have as little energy as possible. For example, when the sun's bright light shines on Earth, it excites the atoms in the atmosphere, causing them to release energy, mostly in the form of heat. Atoms are more stable the less energy they have. All atoms try to release energy to be as stable as possible. It's a very key statement right there. Very important statement. The less energy an atom has, the more stable it is going to be. Right? That makes sense if you think about like a little kid. A little kid is not very stable. They're so full of energy and they're running around and they may be crying and then they may be excited. They're just less stable because they have so much energy, right? So, in science, cold temperature is defined as the absence of heat. This is why outer space, an environment with few to no atoms, has temperatures that can be as low as negative 455 degrees Fahrenheit. Elements. Scientists have determined that there are around 118 different kinds of atoms that exist in nature. Different types of atoms are called elements, and each has been listed in a periodic table of elements. So an element is any substance that cannot be broken down into any similar chemical substance. There are 118 elements. Interesting. Oh, this is cute. This is cute. So here we have a nice little hand-drawn periodic table. So if you've never seen one of these, it may look like a lot, but I promise it's pretty easy to break down. So from left to right, all of these assigned a chemical symbol, which is one or two letters. The first letter is always uppercase, and second letter, if there is one, is lowercase. For example, sodium is Na, magnesium is Mg, sulfur is S. Yeah, we kind of already covered that. Okay. Each square on the periodic table has the same information: the atomic number, the chemical symbol, and the element name, and the average atomic mass. The atomic number is the number of protons an atom contains. Each element has a different number of protons that make it unique. The atomic mass is the average mass of a typical atom of that element. Yeah, there it is. So the atomic mass is a little bit different. It's usually going to be the number of protons plus the number of neutrons. Usually they're the same, so a lot of these will be close to double, but not always. The periodic table is organized by rows and columns. A horizontal row is called a period. A vertical column is called a group or family. The elements are arranged from left to right by increasing atomic number. As you go across from left to right, each element has one or more electron and one more protein than the element to the left of it. For example, hydrogen H has one proton, helium He has two protons, and so on. Elements in the same column have similar physical and chemical properties. Despite elements being different from one another, they are all made up of the same three particles: protons, neutrons, and electrons. Protons, neutrons, electrons, protons, neutrons, electrons. All three of these elements are referred to as subatomic particles. So here you have a little drawing. So you have your protons with the plus because they are positive. Protons are positive. And then the neutrons stick to those in the nucleus. So that's why you usually have one of each. And these electrons out here, you're going to have one negative electron for every positive proton in the middle. So an atom like lithium, right? So an atom like lithium, which has 3 protons, should have 3 electrons, right? To balance out that charge. Goodness. So like this would be helium, right? Because there's 1, 2 protons. 1, 2 protons. Right here, helium. Oh goodness gracious. Yeah, there's 2 electrons as well. So this is what helium would look like. So sub is a prefix meaning under or below. Subatomic means below an atom. Subatomic particles refer to particles that are below an atom in size. So yeah, these are subatomic particles. They're smaller than the whole atom itself. All 3 particles have different qualities. Both protons and electrons contain electrical charges, or quantities of electricity that can be either positive or negative. Protons hold a positive electrical charge. Electrons hold a negative charge. Particles with the same electrical charge tend to repel one another, while those with opposite charges attract one another. Neutrons do not have a charge. Neutrons play a key role in the structure of an atom. The center of an atom is its nucleus, which is made up of both protons and neutrons. The protons within the nucleus give it a positive charge, which attracts the negatively charged electrons, causing the electrons to orbit or move around the nucleus. Atoms that have the same number of protons but different number of neutrons are called isotopes. So I think that's probably a little bit outside of the scope of so small, scientists need to use models to represent them. However, because the atom cannot be seen, since the atom cannot be seen by humans, the model of an atom has changed many times, as scientists have learned more about it. So here's the Rutherford model of the atom by Ernest Rutherford. So this is kind of this is probably what a lot of people think of when they think of like an atom or chemistry or something. I just think of Jimmy Neutron, a whole brain blast moment. But yeah, so this picture, it's kind of like the whole nucleus is just this one big ball of charge, and then the electrons are the little ones going around it. But yeah, so we just know that this isn't necessarily the case because there are different smaller units in here, but as well as the orbits. But the Rutherford model showed the atom as a tiny solar system with electrons orbiting around a nucleus. Ooh, fun. Okay, so electron shell. Electrons move outside the nucleus in various shells or energy levels. Think of shells as rings. The ring closer to the nucleus is numbered 1, followed by the ring around it, number 2, which then has a ring around it, numbered 3, and so on, as they extend outward. The greater the energy of the electron, the higher level shell it occupies, or the farther the outermost ring is from the nucleus. The relationship between the nucleus and the electron shells is similar to the relationship between the planets and the sun within the solar systems. Planets orbit at certain distances away from the sun. Some planets, such as Mercury, Venus, and Earth, have smaller orbits, while Mars, Jupiter, and Saturn have larger orbits. All the planets' orbits are affected by the gravity of the sun. The planets that are farthest from the sun feel less of its gravity. An atom acts as its own solar system. The shells are orbits taken by electrons, and the nucleus is the center that the electrons navigate around. The electrons in the shells closest to the nucleus, or those that have the smallest orbit, are often referred to as the core electrons. Core electrons. The core electrons have the strongest attractive force. They have the strongest attractive force to the positively charged nucleus, and so they are the most stable. Stable subatomic particles have the lowest energy within their atom. So yeah, so like if you think about it, if you have a little circle with the sun, and say it's a magnet, right? Because it's positive, say that's a magnet. If you have an electron right here, it's going to be really attracted. It's going to be really strongly attracted. So it's stuck. It's going to be stuck because it's attracted so well. But once you have further electrons, they're not going to be attracted as much, right? They're going to be a little bit less attracted. So those ones will fly away easier. So the electrons in the shells farthest from the nucleus, those that have the largest orbits, are called valence electrons. Valence electrons are more unstable than core electrons and have the highest energy level. Because of this, they are more likely to break away from the influence of the nucleus. Okay. There can be more than one valence electron within a shell. The maximum number of valence electrons in any orbit is dependent on how small the orbit is. The closer the shell is to the nucleus, the fewer electrons there are. Yeah, so you can see pretty you had a bunch of electrons, they would all be pushing each other away. But since there's only two, they can go around easier. I hope that makes sense. But the shell closest to the nucleus holds a maximum of 2 electrons. The next shell holds a maximum of 8, and the third holds a maximum of 18. Because of an atom's preference for stability, the electrons will always occupy the shells closest to the nucleus, the core shells, before occupying the shells farthest away. So here we have a Bohr model of an atom. Bohr model is a little bit more accurate than the other ones. So the Bohr model of an atom includes the electron shells, but is based on orbiting electrons like the Rutherford model. So the Bohr model shows 8 protons and neutrons in the nucleus of the atom and 2 energy levels with 8 electrons. So yeah, so you have 8 protons in the middle, right? So you're going to have 8 electrons total. Now remember, only 2 electrons can fit in this closed shell. So the 2 go here, and the other 6 have to go out here in this outer shell. But yeah. Atomic bonding. An atom usually seeks to be at its lowest energy state so that it can remain stable. There are 2 exceptions. Energy is added to it, or an atom's valence electron shell is not completely filled. Valence electrons contain a higher energy than other electrons in an atom. When an electron shell is filled, all electrons in that shell behave similarly to core electrons, increasing the atom's stability and lowering its energy. An incomplete valence shell causes attractive forces from the positively charged nucleus to spill out of the atom. Electrons that are nearby will move toward the nucleus and plug those leaks, completing the valence shell in the process. Interesting. Okay. So, the atom with an incomplete valence shell is like a leaky cup of water. Electrons plug the leaks and complete the valence shell. It's kind of an interesting way to draw this, but right, so this outer ring can hold 8 electrons safely. Right now there's only 4. Since there's only 4, this positive charge is able to keep going, right? There's no room stopping this positive energy leaving. Now that all this positive energy is leaving, these electrons are getting attracted, just like a magnet. They want to come in close. So that's kind of a way to describe it. Now, if this outer shell has all 8 that it can hold, no more positive energy is going to leak out, so it'll be stable. So there are many atoms that have incomplete valence shells. These atoms participate in atomic bonding. The process where atoms interact with other atoms to lower their energy. There are different types of atomic bonding. One of the most prevalent is covalent bonding. During this process, atoms share pairs of electrons. They share pairs of electrons. These shared pairs of electrons fill the outermost energy level of the bonded atoms. So, a carbon atom needs 4 electrons to fill its outer energy shell. It bonds with 4 hydrogen atoms to share 1 electron from each atom. So, we have this picture here where this carbon has the 2 in the middle, but it also has 4 extra, right? So it's this atom right here. If we look at this. So remember, there's 4 electrons, and all this energy is spilling out. It's positive energy. So what happens is it attracts this electron, but this electron is attached this is one hydrogen. Okay, it's got the one proton in the middle, and it's got the electron attached. So this is hydrogen. Now this carbon is leaking all this positive energy, so it's like this whole thing is getting a little bit sucked closer and closer, closer, until eventually it goes and they combine right here on the shell. And that'll happen with each one of these to make this. So this electron and this electron make a covalent bond right there. So now this hydrogen has 2 in its inner shell, its core electrons, and this carbon now has 8 in its outer shell. But it's also teamed up with 4 other hydrogens. This is a very common compound in nature of methyl, but it's good old CH4. Okay. Atoms will bond with as many other atoms as necessary to complete their shells. These groupings are called molecules. If a molecule is made of 2 or more different elements, it is called a compound. Some elements are diatomic, meaning that they exist as molecules composed of 2 of the same atom. Diatomic molecules include oxygen, hydrogen, nitrogen, bromine, iodine, fluorine, and chlorine. So it's a diatomic. Very similar, right? They only need 1 more electron in that shell, so why not just share with each other and become stable? So that's what hydrogen does. That's what all these other elements do. They shared like 1 more electron from their outer shell with each other, more or less. Okay, matter. Scientists define anything that takes up space as matter. Matter is created by the various ways that atoms bond. Matter can appear in different states, solid, liquid, or gas. The arrangement of the molecules or atoms, generally called particles, and how they behave determine the characteristics of substances. The amount of movement of the molecules and the distance between them determine its state. So here we have a little diagram. So we have the states of matter. We have solid, liquid, and gas. Now, you all know this, right? So solid is tightly packed atoms. These are rigid. So this is what it looks like. All the atoms are close together, make a hard surface. Examples of this is rocks, ice, and wood. Pretty much anything that's hard, right? This is a solid. My desk is a solid. Book is a solid. Okay. Now a liquid. Atoms are close to one another, but not tightly packed. Items slide past one another, so it does not have a defined shape. This is things like water, blood, or gasoline. Last is going to be a gas. So you can see they're very separated. Atoms are relatively distant from one another. Relatively distant. Air, water vapor, and carbon dioxide are examples of this. But, so this makes a great example here. This is a little bit outside of the scope of this. But you can see ice, water, and air, and water vapor are all water. Yet they can all be different states of matter. So that is dependent later on their temperatures. So most things can be these different matters. It just depends on the temperature, right? So ice, when it's cold, all the atoms bundle up, and they have low energy, so they bundle into one big block of ice. But as they get a little bit warmer and they want to move around a little bit, they turn into water, right? But once they get really hot, they don't want to be anywhere near each other, they run away, So that's a gas, it's a water vapor. Now, bonus points if you actually know the 4th state of matter here. I'm sure you know. You guys are all very smart. I know you're very smart smart people. What the 4th state of matter? I know you know this. Yep, that's right. It is plasma. Plasma is going to be the 4th state of matter. Okay. Now, subatomic. Subatomic. What does that mean to be subatomic? Well, subatomic means, or sub means below. Atomic is an atom, so it's smaller than an atom. Right? Very good, very good, very good. Number 4. What do protons and electrons contain that a neutron does not? I know you know this. I know you know this, right? What do protons and electrons contain that a neutron does not? That's right. It is a charge. Okay. Number 5. Blank electrons are electrons with the shell closest, or with the shells close to the nucleus. Well, if valence electrons are the ones far away, then core electrons are the ones with the shells close. Very good, very good, very good, very good, very good. What is the reason for the small number of electrons in the shell closest to the nucleus? What is the reason for the small number of electrons in the shell closest to the nucleus? That's a little bit of a tricky question. Tricky question. Do you remember that? I know you remember that. That's right. That's right. What is the reason the small number? Because they would repel. They repel. You can't have too many close to each other. They will repel each other. Remember. Good job. Good job. Good job. Good answer. Why does an atom bond? Why does anything bond, really? It's to become more stable, right? I'll just write stability here, but that's why it bonds, to become more stable. More stable. Number 8. What occurs in a covalent bond? Covalent bond. It's important. It's an important bond. It's a very common bond. That's right. They share electrons. Very good, very good, very good, very good, very good, very good. Okay, number 10, or number 9. What is the difference between an atom and a molecule? What is the difference between an atom and a molecule? Well, an atom is the smallest, right? A molecule is just 2 or more of those. Very good, good job, good job, good job, good job. Okay. One more question, one more question, one more question. One more question. Okay. Can we get it right? Can we get it right? I know we can. Okay. Number 10. What is the difference between a solid and a gas? No peeking. No peeking. I know you know this. What is the difference between a solid and a gas? Well, a solid is going to be tightly packed, right? It's going to be rigid, tightly packed atoms. A gas is going to be very distant atoms. Yep. Alright, let's see. Let's check our answer. Let's check. Good. Okay. Yep, 118. Very good, very good, very good, very good. Nice, nice, nice. me know. But yeah, I look forward to hearing from all you guys. I appreciate it so much that you stopped by and